everybody. This is Suvarchala, working as an associate professor, Department of Computer Science and Engineering at Institute of Aeronautical Engineering. So, part of the structured query language facilitates to implement our database management system. In this session, I would like to discuss about triggers and cursors, which are most important concepts in implementation of our database for real-time applications. This lecture includes triggers, different kinds of triggers, statement triggers, row triggers, and also cursors, how the data is going to be stored in temporary work area when retrieved from the database using select statement. Initially, I'll discuss about the triggers. Trigger is an SQL mechanism which is automatically executes a specified PL/SQL block when a triggering event occurs on a table. Triggering event occurs on a table. That means an event occurs, this trigger is going to be get fired. That is, action will be taken place. Whatever the action specified in this trigger, that action will be taken place. The triggering event may be one of any DML statements, insert, delete, or update. And the trigger is associated with database table and is fired when the triggering event takes place on the table. Sometimes triggers can be written as the table level. Sometimes trigger can be written on the, of course, we'll discuss row triggers also. And the triggers can also be implemented on various levels of the data items. So this trigger mechanism can be specified as a ECA, as we discussed earlier, event, condition, action. Event occurs in database, that is addition of rows or updation of rows or deletion of rows, etc. Conditions are checked, is batch completed, has a student passed, or etc. Certain conditions will specify. Based upon the condition satisfaction event occurring, actions are going to be executed. That is, if the conditions are satisfied, whatever the action specified in the trigger, the respective actions are taken. For example, send the batch to the supplier, or if the student passed, congratulate the student, etc. So basically, based upon the current discussion, a trigger will have three components majorly. We'll discuss the various components of the trigger. Trigger event. First component is trigger event. Trigger event is when a DML operation will cause the trigger to execute. So the events are going to be either insertion, update, or delete operations on the table or on rows of a table, or any combination of these two. These three things also. Need not be a single one actually. So whenever these operations are going to be executed on or these operations are happening on your table or row, etc., then what it's supposed to do? This is the event. If this event occurs, what happens or what is the trigger supposed to take an action actually? So when any event occurs, the respective trigger on which the trigger was specified, it will be get fired and action will be taken based upon the statement specified in the trigger. So the next component of a trigger is timing. Timing is when the trigger should get fired. When any event occurs, trigger will fire. Whether the trigger should fire before action, before event, or after event. That is the major timing related concept. So timing means the second component when the trigger should get fired. So there are two options are there, before, after. Before means the code will execute before DML statement or DML event occurs. After means the code will get executed after DML statement implements actually. So third component, trigger body. Trigger body is just like our PL/SQL block, which we discussed some previous sessions, procedures, PL/SQL block, functions, etc. So this trigger body specifies what action supposed to be taken, or when trigger get fired, what is the trigger specified action to be considered. So what action should the trigger perform will be specified in this body of the trigger. The syntax of the body of the trigger is same as our PL SQL block. Declare, begin, exception handling, end will be there. As all of us aware of that, what is PL SQL block. So trigger type, the next component is type of the trigger. That means the type of the trigger is going to be categorized based upon how many number of times that trigger is going to be get fired. So how many times should the trigger body executes when the trigger event takes place? How many times this action has to be takes place? Again, it depends upon the type of the trigger. Basically, there are two types of triggers we can specify: statement trigger and row trigger. By default, if you didn't specify anything, the trigger will be considered as a statement trigger. Statement trigger means when the trigger body is going to be executed once for the triggering, or when the trigger is going to be get fired for the event occurring of the event. That means here statement trigger is going to be executed. That is the actions of a trigger. Statement trigger will be takes place when an event occurs once only. For example, if you are inserting means the data will be inserted only, and at that time only the trigger action are going to be taken place only once. And the second type of trigger or row triggers are there. If row triggers are there, the body executes once for each row affected by the trigger event. So if I am inserting multiple 5 rows, means 5 times this event is going to be considered, no? So that's why 5 times the trigger action will be takes place. So row trigger means the trigger body executes once for each row affected by the triggering event. For example, if you are saying update EMP salary, set EMP salary is equal to, for example, if I am updating by increasing the salary by 5%. Then this update statement is going to be effected for all employees belongs to IT department. That means whenever a faculty or a employee details are related to IT, for each row, this action will take place. I mean, whatever the action is introduced in our trigger. So, summarization here, the type of the triggers are based upon how many number of times the body of trigger get executed. Basically, two types are considered: statement trigger and row trigger. Statement trigger, the body of the trigger executes only once when the event when the event takes place. But in case of row triggers, the trigger body will get execute when an event is going to be executed, and for each row which affects that particular event actually. So statement and low level triggers are going to be executed here. For example, insert into department values, that means one row we are inserting. So when we are inserting here any statement trigger implemented on this particular insert operation, that trigger body is going to be executed. That is, the trigger body executes once for the triggering event. When the insertion, if we already written or we already stored a trigger based upon insert operation without specifying any row concept, then it will be executed. Just now I told you update operation. Update EMP, set salary. Salary is equal to sal plus sal star 1.1, 10% increment we are giving. So update means for each row this updation takes place. Right now, because no where condition, no, so for each row this. For each row, the body of the trigger is going to be get executed. So this is a simple statement trigger. This is a row trigger. Row trigger means the trigger body executes once for each affected by the triggering. So each employee will get modified, no? So for each employee, that means for each row of the employee table, the body of the trigger is going to be get executed once. So it all depends upon our need actually. So create or replace trigger name, timing, event on PLSQL. So create or replace trigger name. I explained you already in procedures we are going to use it to create or replace, but we will use both because initially the trigger may not be correct. Same name if we are going to modify it and execute it, you may not get it actually. So that's why we will use to make the corrections proper way, we are going to use create or replace option. Trigger name. So you can use either before or after. And what are the events? On events names are going to be specified that when the trigger has to be get fired while inserting an element or deleting an element or deleting in a row or updating. On which table the trigger we are writing, table level triggers we are writing the trigger, and what is the action will be written in a PLSQL block. So here, depending on before or after, that means the trigger will get fired, action will take place before insertion or a before deletion or a before updation. If you are using after means once the action will be takes place, after that the trigger is going to be get fired. No? So once the event is going to be considered, first the insertion process or a delete or update process is going to be completed, then the respective actions are going to be taken depending upon the time. Example here, creating a statement trigger here. So we are writing here, this trigger is going to be allow users to insert data into the table EMP only from Monday to Monday and Saturday, Sunday, Tuesday. No insertions are allowed. Okay, Monday, Wednesday, Thursday, Friday. Only these days are insertion allowed. Let us assume that. So, if the current today is, let us assume that today is a Tuesday. Then, if we would like to insert data into the table, it won't allow. It will raise an error that you cannot insert data into EMP during Wednesday to Friday. Only you can insert during Wednesday to Friday. So, Tuesday you cannot insert. So, for example, if you would like to write such a trigger, that means try to insert a data. It will check whether the current or today is from either Friday, Wednesday, Thursday or Friday. Only insertions are allowed. Otherwise, insertions are not allowed. That means whatever we would like to insert the data, it will check and it will allow or not allowed will be specified. No? That means our trigger has to fire before process only. So that's why we are using here creating a trigger before insert, before the processing, before action takes place. Because we are allowing insertion, whether it has to be allowed or not will be decided. No, so that's why the action, whatever the event is to be considered, that event is to be continued or not will be decided no by the trigger. So that's why we are using before here. On which table we are trying to insert the data EMP. This trigger is written on EMP. This is the block. PLSQL block I told you, action. Action will be written in a PLSQL block. Begin. If system date we are taking, from system date we will get the today's date. In that we are converting two character dy part. Dy means day. So already we discussed about built-in functions. System date gives the system date in the format dy mm m yy or yy. So we are converting dy into character type and we are checking in. That means if this from system date, if the day is in these three options, that means if it is Saturday, Sunday, Tuesday. So if these three options, what happens? We should not allow insertions. So then we are raising rise application error. We are raising an error. What is the rise application error? The application error name we are writing -2 0 500 and with a message You can only, this is the application error still already defined in the system. You can only insert data into EMP during Wednesday and Friday. So that's why we supposed to consider in this case when the trigger was written like this, if there are no any syntax errors, we will get output as a trigger created. So when it will be get filed. For example, I would like to insert like this. Insert into EMP number, department number, values. This is insert statement. For example, I would like to insert data by using insert statement on Tuesday. Tuesday means insertions are not allowed. Wednesday to Friday only insertions are allowed. So when I would like to type insert data, I'll get an error. You can only insert the data into EMP during Wednesday to Friday. Today is Tuesday, no? So you cannot insert. If it is Wednesday today, let us assume that I won't get any error. Insertion will be set. That means when this event occurs, before event itself, before means what is event? Inserting record, inserting a tuple. Before itself, the trigger get fired and action was taken. Because we are using before option. If you are using after, what happens? It will insert first. Then it will get fired. There is no meaning, getting such error. So it depends upon the logic which we are going to develop actually. Another example we will consider. This is an example in which any data manipulation language operations, that is insertion, update or delete into the table EMP is valid only on the weekdays, that is Monday to Friday. That means you can do these DML operations, you can perform DML operations only during the weekdays, that is not weekends. So Monday to Friday. As well as the time also we are checking. The time must be from morning 8 to 18, 8 to evening 6 o'clock. During this period only, the operations are allowed, that too on the respective working days. Otherwise, if the working day is not any of these two, that is, if you would like to do any operation on Saturday or Sunday, or if you would like to do any operation, these things are normally happens. For example, when we would like to do some banking applications, during certain hours, the banking online banking, whatever operations you are doing, it won't allow. I'll take some example, LIC, life insurance. Generally, it won't allow any operations between 12 p.m. to 12 a.m. to, it may not allow up to 2 a.m. or like that. So that means these triggers are written on that respective table. That's why we will get the respective messages. So how we are writing? Because you observe here, I have to check whether event is insert, event is update or event is delete. So 3 conditions I have to write. Previously only insert, no. So that's why we have written only insert only. Before insert. Here various DML operations. This is also before. Before only I have to check. If it is condition satisfies, allow your operation. That event is going to be valid. That is the action we are taking. Otherwise, what is the action we are taking? We would like to give a message. So that's why we are checking. First, I have to check the week. How to check week? I am converting my dy into, it will be in the character, no? So SAT or SUN. So if day is either Sunday or Saturday, or 2 character is not between. Not between means it is out of the specified hours. Either of these two satisfies, then don't execute or don't allow the event action. If the days are either Sunday or Saturday, or if the time is other than 6 to morning 8 to evening 6, any other time, then we have to take some action. Error must be displayed. How we are checking? If deleting, if the condition satisfies, then we are writing all these things in the true part. slide is not sufficient, we continued in the next slide. So the then part, true part, if this happens means we should not allow any operations on my EMP table. So if delete, we are erasing an application error. Deleting, some error is there. Else if it is not deleting, else if inserting, then some error. Else if updating, some error. That means we are printing the respective errors. You can insert only on these days. You can insert on during this time. You can delete records only these normal office hours. Okay, so like that we are getting. If none of these operations raise application error, you can only update during the office hours. Then all these are related to end if, and this end if is the first one, and end. This is the PL/SQL block. So that means what happens, this trigger was written on EMP table. If you would like to insert data on any not specified dates or a time, then we will get error like this. Insert employee, we would like to insert the data, EMP number, DEPT, etc. So we are getting only insert data into EMP during office hours. So what are office hours? We defined office hours as Monday to Friday, morning 8 o'clock to evening 6 o'clock. Similarly, update, I would like to try to update on some other time. It won't allow. You will get an error. Right? So even you would like to update normal update also. This is for salary, this is normal update. Any updation. For example, update EMP, set EMP number. Not allowed. Remember, these errors are going to be displayed if you are doing not in office hours. These operations are performed, that means these events are occurring during Monday to Friday, during office hours 8 to 6 p.m. No problem. These are going to be automatically acceptable. This is about the statement trigger. That means whenever any event occurs, it executes only one. The actions are going to be takes place only once. Okay. So for example, even you are using here update operation, it will take only once only, executed only once only, not for each row, because it won't allow to access at all in such cases. Now we'll discuss about the row triggers. Row triggers means here, create or replace trigger name, same. The basic syntax is same, before or after we are using, and we are using on event. What are the events considered? All DML statements, insert, delete and update on table name. Okay, after that, previously this additional things are there. What is this additional thing? For each row, when condition. Condition is going to be optional. If you are just using for each row means it will perform each row. If you are specifying a particular condition, if the condition satisfies, then only for each row, the respective rows only will be trigger, get fired. Action will take place. So here PL/SQL block. That means the action will be written in a page. So what is the additional thing here? So we are writing here for each row what it's supposed to do will be written in a PL/SQL block. But for each row, the block has to be get executed. If I am writing some condition for rows, the condition satisfies for the respective rows only, the action will be takes place. So for create a row trigger to keep running count of DML operations by different users on a database table. Generally, such type of triggers mechanism is most important in auditing our databases also. These type of triggers are already written by the DBA and on various tables so that they'll identify how or what are the tables are going to be accessed by how many users, what are the various operations performed. All this auditing is going to be easily identifiable by administrators of databases by imposing such triggers only. So what is our problem now? We have to create a trigger such that For each DML operation, count must be maintained by us on EMP. So what are the DML operations? Deletion, how many number of times deletion executed, how many number of times insertion executed, how many number of times update executed. All these things must be properly specified. This is going to be maintained by a table, DML EMP table. Right? Such a way we have to create a trigger. So, username and table name, number of operations. So, how to represent? What we supposed to do? We have to count. Counting means when the counting will happen, counting has to be performed after completion of the event. After inserting element, I can add one to count. Insert, one more insert was performed. After completion of delete, I can add successful deletion. That means the count incrementation has to be performed when the event is going to be completed. After completion of event successfully, then only count will get incremented. So that's why what is the time? Time is after. So here we will create after timing trigger. Why? Count has to be incremented. Before I cannot increment because that may be successful, get succeeded or may not be get succeeded. So that's why I am using here after count. So we supposed to understand when we have to use before, when we have to use after, depending upon the action to be taken by the trigger actually. In this, counting has to be incremented. That must be incremented only after successful completion of the respective event, respective operation, that is insert or a delete or a update. That can be done by keep tracking of successful operations. That's why we are using after. And we will use the trigger for, because after each insertion, after each DML, no, that means for each update, etc. So that's why we have to use for each row. We want to count number of rows affected by the DML statement, no? So that's why we have to use row-based triggers. Row-based triggers in place of delete and update operations. So this is the trigger. The first statement is create or replace trigger. I am using DML count underscore EMP trigger name. So what is the time? After we are using after insert or update or a delete. Any of these operations on EMP, this trigger has to be get fired on EMP table. So any operations are we are using, so all, and for each row. Please observe for each row. We are not using any condition, so that's why whichever the rows are get affected by these respective operations, for each row, the action is going to be takes place. Action, what is the action? Incrementation of the count that will be written by us actually. So what we are doing, if deleting, if the operation is deleting, we are updating. DML EMP table was created already by the previous structure. With this structure, a table was created and we are going to update this table by using respective operations. We are deleting. Deleting means which count has to be incremented? Delete count. C delete count has to be incremented. So what we are doing? Update DML EMP table. Set C delete is equal to C delete plus 1. This is incrementation process. Where username is our user and the table name is EMP. So first we will create a table and we will initially create a table and all users are added. For all tables are added, respective operations are initialized 0 first initially. Whenever these operations are executed by respective users, the count is going to be getting incremented. Similarly, else if it is not deleting, inserting, then insert count is incremented. Else if update, salary, update count is incremented, salary update count. Any other updation also going to be update count. Where are these count variables? These variables are stored in a table. That's why we are using updation for change of values. We are using update statement. Remember, this update statement is related to our temporary table or a table created for auditing purpose. How many number of operations are performed? How many number of rows are get affected with the operations? And if. So, for example, if I'm using insert into EMP table, etc., then automatically one insert count is incremented by user Scott. Select star from DML EMP. Then what happens? Scott is having initially 0 and another user is also having initially 0. Once it is inserted, then insertion operation is going to be incremented. When we are updating, 15 rows are updated. For example, what is updated? The update command is EMP set department number is equal to update EMP set department number is equal to 10. For all employees, department number was changed as a 10. How many records are there? How many tuples are there? 15 rows. For 15 rows, it happened, no? So that's why, see, update count was incremented as a 1. So delete count here. This is update count. This is a insertion count. Insertion count is 1 after insertion. Delete after updation, 15 rows got updated. When I am selecting from my DML EMP table, then I got it as insertion 1 and 15 by the user Scott. Like that, we can create triggers, either row level triggers or column level triggers, depending upon the respective process actually. You can, row level triggers are statement triggers actually. So what is it? We discussed already procedures and triggers. What is the basic difference here? Here, it seems trigger is also some a set of actions to be taken. No, it's just like our function or a procedure. But there is a slight difference is there. So we will use syntactically, if you are going to consider, we will use create trigger. Here we are going to use create procedure. Data dictionary contains source and code also. Here also data dictionary contains source and the procedure code, trigger code and procedure code. Commit and rollbacks are not allowed in case of trigger, but in case of procedure, commit and rollbacks are allowed. And triggers we are not explicitly invoking. Please observe. Whenever event occurs, automatically it will get fired. That means we are not explicitly invoking. I created a trigger here. What is the trigger name? Count underscore EMP. I am not invoking anywhere. When it is get invoked, the respective event occurs, insert or update. Any event occurs, automatically it will be get invoked. That means we will call it as a word as the respective trigger is going to be get fired. If I would like to do the same event on a particular table on which the trigger was written, this automatically get fired actually. So that's why triggers are not going to be invoked explicitly, but procedures should invoke explicitly. This is the main difference. Invoking of a trigger is not explicitly. Implicitly by the system, when the respective event occurs, this trigger is going to be get fired. But in case of procedures are executed, procedures are going to be created and kept in our database, and those are going to be invoked by any other procedure or function or a PLSQL block, depending upon need actually. So that's why procedures must invoke explicitly here. That is the basic difference between these two. And while using this trigger, before event occurs, what data will be there? After event occurs, what data will be there? That means we can track such type of old and new values also. For example, if I am updating what is the old salary, what is the new salary, I can keep track of the values. In triggers, we can also track users' activities performed against any table, and we can record the values both before and after data changes by using qualifiers old and new as respective columns. For example, I updated department number in the previous. We will store old and new. That means what is the old department? Before updating, the value that will be stored and the new value will be stored in the respective column name only, but both are qualified by the old and new. For example, department number. So old colon department number, new colon department number will be there. So how to make use of this old and new? By using our row triggers, and the syntax is create or replace, trigger name, before or after, and event on any insert, delete or update on table name up to this same, and remaining part also for each row, and PLSQL block is also same. In between we introduce the new thing. What is that? Referencing old as a small old, new as a small new. That means before updation, we are going to store the value of the old one also. So for example, create a table, audit TMP values, username, where character, times, date, ID, old e-name, new e-name, old salary, new salary. We are maintaining this as a audit for auditing. What is the old value? What is the current new value? These are all stored internally for auditing purpose. Just like that, we have discussed earlier for that purpose. So we are creating a table which will store old values as well as new values. This is the table. Updations are made on most of the time salary, no? So that's why employee, whichever the attributes you would like to store, first you create a table like this and store, which consists of both old values and new values. Now the trigger that will track user activities performed against TMP table, we will record the values both before and after data changes. So this is the example, create or replace trigger after delete or insert or update for each row, begin, insert into insert audit table values by using old ename and new ename. So when I am executing insert table, automatically in my audit table it happens. What are the data inserting? I am inserting username, timestamp, what is new name, and the new salary will be, because there is no old here, because we are inserting no old. If you are taking update means for a particular employee 111 for 4 months we are updating. So we are salary we are updating as a 6,000. So got time, ID, which employee ID? 41's employee ID. Old value is old name is test. New name is also test. Test was not updated. And old salary is 5,000. New salary is 6,000. So delete. When I am deleting also, for example, test I am deleting. One row will be get deleted. And the old values are going to be returned. What is the old value? Old value is going to be test. And old salary is equal to 6,000. New salary is no. Because deleting deleted no value. For new name is also no value. Please observe this. These are new. Because of deletion and updation, old values will be there, new values will be there. For insertion, no old values will be there. Old values are blank, only new values are going to be there. Insertion and deletion can be considered as a reversal. In case of insertion, no old values, only new values. In case of deletion, only old values, no new values. Only in case of update, old and new value. You observe here, this old new means before operation occurs and after operation occurs if any updation process was carried out. So when we are considering these triggers, various syntaxes we keep on added. So that's why this is the complete syntax of our trigger, definition, create, and before or after. These are all syntax specifications. Flower brackets means any one of them must be used by us. Then events. Events are delete, insert, update. Column level means of respective column also we can write. Triggers can be written on table, on columns also. So that's why you can use the column names also. Okay, or delete, insert, etc. And on table, respective table name. And we introduced referencing old as old and new as new to store our new values and old values. If it is a row trigger, for each row we will write, this is also an optional, when condition occurs. And this is the PLSQL block. PLSQL block is the action. So this is the entire trigger syntax. Initially we started with a simple trigger and keep on adding all options. This is the final syntax of the trigger. So when we are executing the trigger, the order of the execution of a trigger is first it executes all before statements, then it disables the temporarily all integrity constraints recorded again as the table. Please observe that temporarily disable the integrity constraints, loops for each row in the table if it is a row level trigger. That means executes all before row triggers, then executes various triggers will be there, need not be always a single one. I'll write various triggers on my table and columns, etc. And all of them will be get executed within a loop. Execute all before triggers first, execute the SQL statement, again the row and perform integrity constraint checking of the row, then after row. So multiple triggers are there. First before triggers are executed, then the SQL statement level triggers are going to be executed by checking the constraints, integrity constraints. Then after row triggers are executed. Then complete deferred integrity constraint, checking again as the table. Complete because initially disabled, no, after completion of this process, first the integrity constraints are checked. Remember, always we define integrity constraints such that it always maintains the integrity of the correctness of the data of a database from accidental changes actually. So that's why it will check against the entire table, then executes after statement triggers actually. So what are the rules we will follow generally? Do not change the data in a primary key, foreign key or unique key columns of any table. If you follow like this, then it will happens. No, what happens? No, the accidental, any loss to the data can be avoidable. Do not update records in the same table you read during the same transaction. While reading, updations are not possible. And do not aggregate over the same table which we are updating. Okay, while updations are going on, aggregations are not. Better not to use aggregations. And do not read from a table which is updated during the same transaction. All these things we discussed already while doing transaction processing also. So when updations are going on, if I am reading, then problem may arise actually. Do not use any data control statements also in triggers. These are the some of the rules. If you follow, then implementation of triggers on our any real-time application may not result in loss of information. And I would like to introduce about cursors also in this session, because we introduced how the data can be, catched by simple variables. But it's not always possible because the result of a select statement may be in the form of tables, not a single value. So that's why sometimes these result of the select statement must be used by us for some applications. So if it consists of more than one row and one column, then we cannot use into option which we were used in our procedures, etc. Into option is only for a one variable only. So for multiple rows and multiple columns are there, we cannot use into. Even multiple columns are there, variables can be considered. But multiple rows are there, it's not possible. So that's why PL/SQL cursor allows the program to fetch and process the information from the database into a PL/SQL program, one row at a time actually. That means whatever we are data resulted from a select statement will be stored in a work area. From that we will use the tuples or records to process our application. So where it has to be stored, some work area means cursors. We will use the word as a cursor. So cursors allowed embedded SQL statement. That means a cursor will store result of a temporary, it is a temporary work area used to, which will for storing the result of any select statement. And cursor name permits iterative manipulation of the rows. I can manipulate. And actually, even we didn't notice that we have been using these cursors for normal execution of our select statements also. So the cursors are of two types, implicit cursors and explicit cursors. Implicit cursors are automatically created when select statements are going to be executed. So whenever we are using some select statement, the result is going to, well, it will be stored in a implicit cursor. One implicit cursor is there. In that it will store by the system itself actually. So same name is used. Next select statement, another statement executed means the result of the recent will be stored in that particular implicit cursor. So we cannot manage by accessing the data. We can access actually. So that's why the recent data will be stored in that actually. And another kind of cursors are known as explicit cursors. Because what is our problem here? We have to catch the data and we have to use further in our application. That means it has to be stored in temporary work area. No? So that's why explicitly we will assign some work area to store our results. Those are known as explicit cursors. So explicit cursors need to be defined by us explicitly, as well as we have to provide some name, and through that particular name we would like to access data in the explicit cursor actually. So what is a cursor? Cursor is a work area in which the result of any select statement will be stored. Basically, there are two types of cursors. One is implicit cursor, another one is explicit cursor. Implicit cursor means defined by the system itself. The result of a select statement is generally stored in the implicit cursor. So recent select statement results are stored in the implicit cursor. But we want to use that result for our application whenever we want. So that's why we will store temporarily the result of any select statement in some work area that we will consider it as an explicit cursor. Explicit means we have to define explicitly by giving a name to that in which the data will be stored. Result of a select statement will be stored. So this is the simple cursor. That means the declare. We are declaring a cursor through some select statement. That means whatever the result of the select statement, select star from EMP, no, the data will be stored in a cursor C1. Okay, so and we will use this C1 data in this logic. Begin, just we are using a for loop printing the data. For EMP underscore REC in C1 loop we are writing DBMS output. That means we are just each row of C1 is transferred here. That row is printed here. Already I explained you DBMS output line package as well as a put line package during procedures and functions. So this is a simple cursor. Create or replace procedure some salary is, for example, we would like to find out the sum of the salaries. For that I am creating a cursor. Cursor C1 is select star from EMP. This is declaration part. And I have to store some of the salary values. No? So that's why I am using a sal sum as a one variable, local variable I am using. And SQL block is begin. Sal sum is 0 initially. Each record I am taking, where are the records are stored in C1. So for EMP underscore in C1 loop I am starting. Sal sum is equal to sal sum plus EMP record. Current record was stored, no? Dot SCL I am using. Dot SCL means HCL is the attribute name of the respective result of select statement actually. And this is loop, end loop. This process is executed as long as the data is there in your C1. That means if 10 records are there, 10 times. 20 records are there, 20 times, etc. After completion of the loop, I am printing some of the salaries and procedure is going to be created and we will execute like this. So for this cursor, I am using in a procedure. So this is a procedure to calculate the sum of the salaries. Of course, another process is there that is different, just to show the application of a cursor. So this is a procedure, sum salary procedure, and I've created procedure and execute means I'll get the result here. So we can use these cursors in triggers or we can use in any action part, that is procedures, functions, PLSQL block, etc. where you would like to apply some logic on the each row or some rows of results of the any select statement actually. So By example, which we discussed earlier, now these are the operations we can perform with explicit cursors. That is declare, open, fetch, test, and close. So declare declares the introduce the cursor object bound to the SQL statement. This declaration part is associated with some select statement. Open constructs the temporary table. We will open the cursor, and fetch access the next row. Fetch command is used to access the next row of a cursor, and we are using found, not found, row count, is open are the some testing functions. The terms itself indicates something found, row found or not found, row count, total number of rows available in your cursor, and if the cursor open or closed, that will be checked. Close means closing of the cursor. That means it results the temporary table was created in memory, that is going to be working area easily, that will be released to the OS actually. So for example, as I told you, declare introduces the cursor object bound to some SQL statement. For example, cursor EMP cursor is select EMP name, ename, salary from EMP. That means from EMP table, all rows, only these 3 columns are stored in a temporary work area table, EMP underscore cursor. So it is a temporary table only. It will have the attribute names EMP name, EMP number, and salary. So once it is created, we can use open. So open construct temporary table. So it will use begin, open, cursor name. Fetch means it will be in the loop. We will write loop, and fetch statement is associated with the variable, record like that variable into these attributes. That is EMP cursor is going to be the attributes are stored. How many attributes? EMP number, ename, salary are there. EMP number is stored in V, ename is stored in V underscore ename, and salary will be stored in V salary. What are these things? These things are temporary variables, local variables we will call it as. So the current record of the EMP cursor are stored in this variable. So I will use these variables to process something. Close releases the temporary table. The syntax is close and cursor name. And we can use, as I told you, found. That means when we are fetching the record, if not found, we will do. If there is no row, row cannot be found. So we will write some condition. Exit when EMP cursor not found. Generally, all these operations are, all these testing conditions are associated with the cursor name. Cursor name, percent found, cursor name, percent not found, cursor name, percent row count, cursor name, percent is open. So that's why if not found means if the row is not available, you can exit. Till then, we will do this process. What we are doing? If salary is greater than 1000, then we are printing. Otherwise, we are printing the salary is less than 1000. A simple logic. So what we are doing here, loop, fetch EMP cursor into, that means the values are stored EMP number, V name, and V salary. Exit when EMP cursor not found. That means the records are exhausted. It will be result. The loop is going to be exit. Otherwise, the loop will be get executed. What is then we are doing? Salary greater than 1000. We are printing just employee name, number, and salary. If it is less than 1000, we are printing the message as a particular employee name and less than. Another problem is there. We will retrieve all records from EMP table and display them one by one by using cursors with some data manipulation. So how many? 3 attributes are there. EMP number, ename, and EMP salary. 3 attributes we are declaring as local variables of the respective attribute types. And we are opening a cursor here with a select statement, EMP underscore cursor. We are beginning the logic. What is the logic? The cursor was created here. We are opening the cursor. Open EMP cursor. You visualize it as just like a files. A cursor is a temporary area. File is a physical permanent area. Okay. File permanently stores the data, but here cursor doesn't store. Similar to that only. And loop we are starting, we are reading the first fetch means reading the first record, the current record. Exit when found means if no records, it will be stopped. And we are doing the same process. After completion of the entire thing, we are closing and we are printing a message execution completed. So observe here delete, declaration, opening, fetching, testing, and closing. Another example is also there, similar to that. When exit when cursor not found, and just we are printing by separating A and B. Employee name and number we are printing as it is. And also we would like to print by using row type. We are defining a row type, emp cursor, emp% row type means variable cursor consists of all row values, whatever the row categories are there, those are going to be declared actually. And similarly, fetching limited rows may not be all rows. I can stop, for example, exit when emp cursor row count is equal to 5. That means up to 5 records only the process is going to be continued. When the row count comes to 5, then only exit. First 4 rows only it will be executed. Like that, we can perform any number of cursors. By using these procedures, cursors, and triggers, we can implement whatever the programming language thing performs. All those can be implemented in your database applications. So, PLSQL supports us a lot to implement users logic on database data so that we can generate our own applications and use those applications by other levels of users also. Thanks for watching the video.
Like, share and subscribe. Hit the bell icon for more updates.